friends, welcome to another lecture of Fourier series, that is lecture number 3, and I have given the links of the first two lectures in the description box. If you want to watch them, you may go through. And here we're gonna solve these two questions. These are two very important questions, and we're gonna solve these two questions in this video. And if you think my videos are helpful, please share with your friends, hit the thumbs up button. And if you're new to my channel, please subscribe the channel, stay connected, and also hit the bell icon so that you get notified when new video will be uploaded. Okay, and if the lecture 4 is already uploaded, if it is uploaded, then it must be appearing at the end of the screen. If not uploaded yet, then you're gonna find it later. Okay, so solve the first question. This is the first question. Obtain the Fourier series of the function f of x e to the power minus x in the interval x greater than 0 less than 2 pi, right? So let's solution. First let me write the given function, that is e to the power minus x, and let us consider this Fourier series of this function be a naught by 2 plus summation from n equal to 1 to infinity a n cos nx plus summation n is equal to 1 to infinity bn sin nx, right? And let it be equation number 1, right? So now we know that an is given by this 1 by pi integration 0 to 2 pi. Here interval is 0 to 2 pi, right? And f of x dx. So here f of x is e to the power minus x. So let me integrate this, and integrating this we have got e to the power minus x is integration of e to the power minus x, that's going to be minus e to the power minus x, and we are integrating it from 0 to 2 pi, and if you put the upper limits and lower limits, then you're gonna get this value, right? E to the power 0 is that's gonna be 1. So here this is the result we're gonna get. Okay, so now you see this is what now let me show you how to find a. Okay, an, that's gonna be equal to an is equal to 1 by pi integration 0 to 2 pi, again f of x, here cos nx dx, right? So f of x is e to the power minus x. Let us put that, and doing so we have got this. Now let us integrate this. So here we're going to use this formula, integration e to the power ax cos nx dx, that's going to be e to the power ax by a square plus ns square into a cos nx plus n sin nx. So here you see this is a naught. Let me write here a naught, just do it. This is a naught. Okay, now here you see, if you compare this, if you use this formula here, then you can see that clearly here e to the power ax is e to the power minus x, so value of a is minus 1, and so integrating this we're gonna get, let me write in the next page. So let me go to the next slide. So here we're gonna get this is equal to, this one. Okay, so using this formula, what we have got, so let me use this formula here. I am writing again. Okay, comparing these two, here a is minus 1, so integration of this will be e to the power minus x by minus 1 square, that's going to be 1 only, then plus n square, and here we have value of a, that is minus 1, so minus cos nx plus n sin nx, right? So this is the integration of this is the result of this integration, and here you can see, and here we have used this formula. Okay, so hope you have understood this. Now let me use this result here, so then we will get an is equal to this, right? So let me write that one. Okay, so here the limits are 0 to 2 pi, and if you put the upper and lower limits, then you will get this result, right? So here you see, and as sin n twice pi, that's sin n twice pi, sin n pi is always 0, so definitely sin n twice pi, that's going to be only 0. So we're going to dealing with this term only, and putting the upper and lower limit, we have got these results. So hope you have understood this, right? So here e to the power 0, anything to the power 0 is always 1, so our result going to be equal to, and cos 0 is also 1, and sine and cos n pi, just wait, cos n pi is minus 1 to the power n, and when we write cos twice n pi, twice n definitely even number, so that's going to be plus 1, right? So this result is plus 1, as there is minus, so it's going to be minus 1, and hence the result becomes this, right? So this is an. Okay, so hope you have understood this. Now let me go to the next slide. What we're going to get here, bn, that is 1 by pi integration 0 to 2 pi f of x dx f of x sine nx dx, and let me put the value of f of x, that is e to the power minus x sine nx, and here we're going to use this formula, right? This is the formula we're going to use here, and value of a is here minus 1 again. So using this, let me file okay, using this formula we're going to get this result, right? So here again you can see that cos n pi x, if you put here twice pi, that's going to be 0, right? So we're going to deal with this term only, and doing so, putting the upper and lower limits, we're going to get this result. So hope I think that you can simplify yourself these things. Okay, very simple. So cos 0 is 1, and anything to the power 0 is also 1. So here, and cos twice n pi, that is also 1. Because of this minus, there will be minus n into 1 minus n, right? So our result will be this. So let me write the result here. So this is nothing but bn, right? So we have got an, bn, a naught, right? So let me go to the next slide, and so let me write the values of a naught. This is a naught, right? This is b naught, n, and this is b naught. This is the value of b naught, bn, not b naught. So bn. Now we have a naught, an, bn, right? So what? Let us use those values in equation number 1. What was the equation number 1? This is the equation number 1. Let me write the equation number 1 again here. So this is the equation number 1. This was the equation number 1. Putting the values of a naught, an, bn, right, in equation number 1, right? And if you use those values in equation number 1, then you will get this result. So here is the result, right? This is the result you're gonna get. Okay, so now if you expand this series, okay, so if you expand this series, now you can see this okay, just wait, you can write this way. Then here this part can be taken outside the summation, because there is no n, because we're going to put the value of value 1 to infinity in place of n. So we can take out 1 minus e to the power minus twice pi outside the summation, this part, right, outside the summation, and that's why we got this, right? Now let's put n is equal to 1, n is equal to 2 up to infinity. We're gonna get this result. Just first let me write as a summation, and here also this part is taken out. Okay, excluding n, this part is taken out, right? So as there is no n, okay, then we have got this result. Okay, in order to expand, let me write here. Let me write the last result again. Okay, this is the last result I have got. Okay, so now let us expand this. If you put the value of n from 1 to infinity, this series becomes something like this. So I hope you can you will able to simplify this, right? Just wait. Here I have taken this part common. Okay, these two terms common here. Okay, then now let me expand this. Okay, if you put the value of n from 1 to infinity, then you will get this from this part, right? Dot 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 so on. And again, if you expand this part, then you will get this result, right? So here I should have I should write here 1 square. Okay, 1 plus 1 square, that is the result we're gonna get, right? So this is our required series. So hope you have understood this. Now let's move on to the next question. Okay, so find the Fourier series to represent the function f of x e to the power x within this interval, right? E to the power x, not ax, e to the power x. The previous one was e to the power minus x. Hence, derive a series for this pi by sine hyperbolic pi. Okay, first let me obtain the Fourier series for e to the power x. So this is the function f of x e to the power x. Let it be this is the Fourier series, suppose, and let it be equation number 1. Okay, so then how to find a naught? We know that I have already explained many times in this video as well as in previous videos also. How to find n we have already discussed. So now here interval is minus pi to plus pi, so f of x dx, and if you put f of x is equal to e to the power x dx, again here the result gonna be e to the power x. After integration of e to the power x is simply e to the power x, right? Now put upper limit and lower limit, that is pi and minus pi, then your result is gonna be this, right? So here you can see this can be written as, now just wait, 2 by pi sine hyperbolic pi. How? So because sine hyperbolic pi is e to the power pi minus e to the power pi, e to the power minus pi divided by 2, that's why this part will be equal to 2 sine hyperbolic pi, and this 2 is written here. So hope you have understood this. So now just wait, let me clean these things. Okay, so now this is a naught, right? Now let's find an. We know that is also how to find an, right? So f of x cos nx dx. So integrate this part using this formula. So let me write this one first, e to the power x cos nx dx. So which formula we're going to use here? So this is the result, should be, and this is minus pi to plus pi, and let me write the formula that I have used here. So this is the formula that I have used here, right? So I have already mentioned in the previous problem also. So here value of a is your plus 1, right? Here value of a is plus 1. Okay, this a is plus 1 because e to the power x, the function is e to the power x, means 1 into x. So that's why we can say that value of a is 1. Okay, so let me go to the next slide. So here is the n. So let me write the last step again. So this is the last step that I have written in the previous slide. So okay, so now if you put the upper limit and lower limit, then you're gonna get this result, right? This is the result you're gonna get, because you see this part will be definitely 0, sine n pi, that's gonna be equal to 0. So we're gonna dealing with this cos nx, right? And cos nx, that's gonna be 1 to the power minus n, right? So the result will be something like this, right? So okay, this is equal to, so here you can see this is replaced by 2 sine hyperbolic pi. Why? That is already explained in the last step, right? So this is what, this is the value of cos n pi, right? So bn, how to find bn? We know that one also, right? E to the power x, now sine nx dx, and if you integrate this, then you're gonna get this result. So here what formula I have used here, let me mention here. Just first let me write the result here. Okay, this is the result we have got. Okay, just wait. Here you can see that here I have used this formula, that integration of e to the power x sine nx that is given by e to the power ax by a square plus n square a sin nx minus n cos nx, right? So here value of a, if you compare a to the power e to the power ax with e to the power x, then you will get a is equal to 1, and putting this replacing this a is by 1, we have got this result, right? Then I have put upper limit and lower limit, and this term going to be 0 because sin n pi, that's going to be 0, and this n we're going to dealing with this term only. If you put cos n pi or minus n pi, because cos minus theta is cos theta, so doesn't matter if you put cos n pi or minus pi, cos minus n pi, in both cases value will be same, right? Value of cos of minus n pi and plus n pi, if you put plus pi and minus pi, in both cases the value will be same. But here you will get when you will put e plus pi, then you will get this result. When you will put minus pi here, then you will get this result. So hope you have understood this. So from these two terms we can take n cos n common. So cos n common, this n is taken common, and then here you see, then we have e to the power pi minus e to the power minus pi, right? Okay, because this minus is also taken common. Then if you divide this term, e to the power pi minus e to the power minus pi is divided by 2, so one more 2 is multiplied here, so that if you cancel these two, then again you get this term, right? So hope you have understood this. So now where I have multiplied both the numerator and denominator by 2, because e to the power pi minus e to the power minus pi by 2, that is sine hyperbolic, right? Pi. Okay, so what we have got? We have got this result. So this is nothing but bn, sine hyperbolic pi. So cos n pi is this, minus 1 to the power n. So we're going to use the value of putting the values of a naught, a n, b n in equation number 1. So what you will get? So this was the equation number 1. Let me write the equation number 1 here. This is equation number 1, right? This was equation number 1, and a naught was, this is the value of a naught, 2 by pi sine hyperbolic, and n is this was n. We have already found that this is the value of n, and bn is this one. So we put bn, a naught, an in this above equation number 1, and doing so we have got this result, right? So this is the result we have got. Okay, just wait, right? So this is the result we have got. Now this is the required Fourier series for the given function, that is e to the power x. Now you can see there is another part in this question, that is what? So this part, sorry, we have to derive a series for this as a pi by sine hyperbolic pi. So let me go to that now here. So this is the Fourier series of the given function e to the power x. So now e to the power, this can be written like this way, just wait. Now x, okay, so 2 and sine hyperbolic pi, those things not containing n are taken out, this pi also taken out of the summation, right? So, and let us put the value of n is equal to 1 up to infinity, and doing so we're gonna get this series, right? And from the next part, this part here also, minus 2 sine hyperbolic pi and pi divided by pi is taken common. Okay, so minus is kept inside, right? Not taken as common. And here you see, for n is equal to 1, we will get minus 1 to the power 1, that's going to be minus 1, as we have already minus is one minus is there, so minus minus it's going to be plus, and the next term will be minus, because you can see when you will put n is equal to 2, that is even, so minus 1 to the power 2, sorry, minus 1 to the power 2, that's going to be 1, and 1 into minus 1, that's going to be again minus, right? So hope you have understood these things. So let me complete this, just wait. So here I have sine, okay, 1 is square. So next term is this, okay, and so on, right? So that is what we have got. So this is the final result. Here you see, let me write the last result again. Okay, just wait. So now what we can do, we can take this common, we can take this part common, right? And then we will get this result. So we have got this, and okay, there should be a half, right? So this is our result. Just wait. This sign should be negative, right? Because there is minus 1, so it should be negative. So let me write here minus sign, okay? So now let me continue. So this is the result we should get, okay? So now what we're gonna do, that we're gonna need a series for pi sine hyperbolic pi, right? So that's why we're gonna put e to the power x. So we're gonna put x is equal to 0, right? We're gonna put x is equal to 0. Let me go to the next slide. So here is the last line, last step we have got, and here let us put x is equal to 0, and doing so we have got this result. Putting x is equal to 0, we have got this result, right? You can see that what we have done here, I have multiplied this 2 with this half, so I have got 1, and from the next remaining part I have kept the 2 outside instead of multiplying with the remaining terms, okay? Just let me keep it here. This is the series required for this expression. So hope you have understood this, and in the next video, before we go to the next topic, we are going to solve another problem, another important problem. Then we're gonna move on to the next topic of this Fourier series, okay? We're gonna discuss about subrange, okay? Defining the function defining 2 or more subranges. And before going to that topic, I will show you another important problem in the next video. Then we're gonna discuss about the next topic, function defining 2 or more subranges, okay? So hope you have understood, and please share with your friends. Please share my videos and hit the thumbs up button. Also subscribe the channel if you're new to my channel, and hit the bell icon so that you get notified when new video will be uploaded, okay? So thank you for watching. See you in the next video.